So today's fairly straightforward. It's a lot of what we're going to do is really easy, but it's a big idea, and then we extend it to a special case tomorrow, which is really important. Okay, but what I will tell you is it's funny how we do this day on what we call remainder theorem, and then if we put a question on a test, people don't recognize it as a remainder theorem type question, and it makes it a lot harder. So although essentially the idea that we're going to do here is simple, you really want to remember this little tool and use it when you can, because it'll make, like if you miss it, it makes a question a lot harder. So, remainder theorem. And we're not actually factoring today. This part's wrong. Oh dear. Get rid of that. Okay, remainder theorem says that, and again, the definition, you're going to be like, huh, what? But it's actually really straightforward. If a function f at x is divided by some, in this case, linear polynomial, x minus a, so that's, we've been doing a lot of that, right? Don't be confused by that, like x plus 2 or x minus 5 or something like that. If we divide one polynomial by another, the remainder is the function evaluated at a. Do you understand what that means? If not, let's see an example what that means. If we were doing this question yesterday for the function f at x equals so on and so forth, determine the remainder if you divide it by x plus 1. How would you have done that yesterday? You would have done long division or synthetic division to figure out the remainder. But it turns out that I can just, so if it's x plus 1, means a is what?
1.
Close? Negative 1. Because it's x minus a, so what would this be subtracting? So that's something we're used to, is changing the sign. So we do f at negative 1. That's obviously important. If you got the sign wrong, it's not going to work out. Equals 2 times negative 1 to the 4th, plus 5 times negative 1 to the 3rd, minus 29 times negative 1 squared, minus 38 times negative 1, plus 120. Whew. Okay, try that on your calculator. We're going to be, over the next little while, doing a lot of this, evaluating functions at a particular value. And you're going to do it like over and over and over again. So you actually do want to get good at this. Little tricks like doing the one part in your head, not punching that into your calculator. So negative 1 to the 4th is going to give me positive 1. So that's just going to be 2. And then minus 5, because the next term is going to be negative 1 times 5, so minus 5. And then minus 29 plus 38 plus 120, I think. But you do it yourself and see what you get. What did we get? Got 50? Anybody else get 50? Anybody else get 50? Yes? No? Did anybody else do it? That's not what I got. What'd you get? 126, that's what I got. Anybody else got 126? Okay, let's just check again. Again, it's easy to make a little mistake with pluses or minus here, so just be careful. You don't want to mess this up. In fact, this becomes, like I said, what we're going to do, we're going to use a special case of this, but this becomes like a small step in a much bigger process of what we're going to do starting tomorrow and then for sort of the rest of this unit and a bunch of next unit. So you're going to do this a bunch of times, and if you make a mistake, that could really mess things up. So be careful. Okay, try the next one. Same thing, but for -2 makes it a little bit harder. What's my a value if I'm dividing by x minus 2? Deal, what'd you put?
2.
+2. Good. So again, in your head, you could do something like 2 times 16 plus 5 times 8 minus 29 times 4 minus 38 times 2 plus 120, and put that into your calculator kind of thing. Yeah?
Do you have to write these statements before we read for x, dx times qx?
No. No, because we don't know what qx is. So you wouldn't write a division statement in this case. How about we're going to add to our lesson at least, therefore, the remainder is 126. Just so if we're looking back at our notes, it's obvious. You wouldn't even need to do that for a test, because if you show these two steps and get the right answer, like that's you showing that you found the remainder. But if it was a bigger problem and this was just part of it, maybe you would say the remainder is 126, just to be clear. I don't know. What do you get for this one? Anybody? 0. Anybody else get 0? Nice. We talked about this yesterday. That can certainly happen. What happens when you have a remainder of 0? Oh, geez. That happened yesterday. I was able to fix it, but it was weird. Therefore, the remainder. Okay, you write it down. Is 0. Okay, everybody got that okay? Very quickly, I want to talk about why this works. I don't think why this works will help you remember what remainder theorem is. I don't think, for some people maybe it does, I don't know, but it's just kind of interesting. It only takes a second for us to really think about this. And so it's just kind of interesting, I think. So we have f at x is equal to, remember this is our division statement, d at x times q at x. It's like growing. It's like a cancerous tumor growing on our note over there. Plus r at x. Okay, so think about what this means. If I divide f at x by x minus 5, I'm going to get f at x equals, oh my gosh, x minus 5 times, all I know is q at x because we haven't actually done this yet, plus r at x, right? This is our summary statement. Like, this is always true. Do you agree with this? By definition, this is how it works out. So what happens, what would my a value be in this case? 5. So what happens if I do f at 5? I get 5 minus 5 times q at x. Does anybody see what happens here? What happens? Jason?
5 minus 5 would be 0, then multiply that by q at x, doesn't really matter.
Very nice. This is going to be 0 no matter what. Like, that's how we set it up. That's by definition. This is, right? We picked the value that will make that 0. That makes that whole part go away, and we have to be left with r at x. So of course it makes sense. Of course that's going to work. Okay? Is that, everybody okay with that? Here's a little thing to think about. How would you determine the remainder when considering all of that? If you were finding the remainder when you're dividing by 2x plus 3, and I'm actually not going to answer this question, but if you want to, I want you to come up with your own answer, and I'll tell you after if you're right or wrong, but I want you to think about this. So it's like f at what value? Like, what would you do? And I'll give you a hint. Thinking about this right here will help, because it's got to satisfy that little thinking piece that we just did. How many people think they have an idea? Okay, so I'm going to leave that with you to think about. And we're going to do one more kind of example that's a little bit different. So this is going to be one of those questions that I don't think is too tricky. But if you didn't recognize it for what it was, it's the kind of question where if you don't recognize it and you start doing something wrong, it's probably not going to work out. Or it's a bit of like a math class kind of question. So if you weren't here today, or if you didn't look over the note or try a few of these, you might be kind of stuck. But once you recognize this kind of question for what it is, and you know how to do it, you've done it a few times, pretty straightforward, pretty easy, I think. So before we start, any question on a quiz or a test, if it's slightly different from this one or totally different from this one, but talks about the remainder in some way, like gives you the remainder or asks what is the remainder or something like that, even if it's not quite the same, I would immediately be thinking, hey, can I use remainder theorem for this? You know what I mean? Like any kind of question like that. That would be my first go-to. And then maybe the answer is no, and you have to do something else that we do this unit. But there's a good chance that the answer is yes, you're going to use remainder theorem at some point. So there's a heads up that there are different kinds of questions, and we're not going to do every type together. Some are going to be in the homework. This is one type. But there's sort of a bunch of other, all different kinds of questions that I can think of that might pop up that has to do something with remainder theorem. And sometimes if people don't notice and they don't get it, it makes it very hard. Whereas it's like a 1 or 2 mark question. It's a pretty straightforward question. Okay, so when the function a at x cubed plus x squared minus 7x plus b is divided by x plus 1, the remainder is 10. When the same function is divided by x minus 3, the remainder is 46. Find a and b. Anybody have any idea about like how we might be able to start this or what maybe we can do?
You can start it by using the x plus 1 and 10 and start it off like how we would the other ones, like subbing in the negative 1.
Okay, I love it. Okay, I'm gonna do a little bit of that. I'm gonna start with f at x because it wasn't written this way, but equals ax cubed plus x squared minus 7x plus b. And what you're telling me is to do f at what?
Negative 1.
Negative 1 equals a times -1 cubed plus -1 squared minus 7. What made you think of that?
You have all the information you need to do that, and then certain things will, like the second and third term in the function, you can then combine those.
Do some work. Yeah. Oh, nice. I like it.
So you can simplify it down, and then if you do the same thing with the other one, then you can.
I like it. The other thing is, what else can we do? I mean, unless I'm going to show you some fancy trick, which I'm not really. Like, what else can you do? You're given a function that has some x's in it. You're given a possible value of x. Sub in. See what happens. There's one piece missing from this, and Emma, I'm not sure if you wanted me to do that, and I didn't do it on purpose, but there's one other piece missing to this that I could add to it. Does anybody else, before we start doing what you said, what do you think? It equals 10. How do you know? It gave us that. So I could have actually, so I didn't on purpose, like I said, but I could have actually said 10 equals all of this. So now I'm going to simplify as well. -1 cubed is -1, so this is -a. And then that's 1, I'll do it the long way, plus 1 plus 7 plus b. So that's 8. So I'm going to move the 8 to the other side just because why not? Because I've got a number over there too. Put them all together. And it looks like I get 2 equals -a plus b. Are we happy with that? Everybody okay with the algebra there? What else can we do? What can we do now? Somebody else. Come on. Think. Read the question carefully. When the same function is divided by x minus 3, the remainder is 46.
The same thing for fx.
Yeah, why not? Why will that help us? I'm not actually asking you. Why will that help us? Well, let's do it and we'll see. Go ahead and evaluate that. See if you can simplify it. I got that. 58 equals 27a plus b. Anybody else get that? Awesome. So now what? What's our ultimate goal? Find a and b. Have we done that? No. What can we do? Okay, a couple people know anybody else? What did I say at the beginning of this course? It all comes back to grade 10, doesn't it? So we learned so many fundamental skills in grade 10. It's like in elementary school, you spend a few grades learning to add and multiply, and then you do a bunch of boring stuff with that. And then all of a sudden in grade 10, you learn some new important things. Ah, that's really interesting. Now that is, yes, although that may not get us our answer. But if two things equal the same thing, they equal each other, what we're going to do is like that same idea. That's just a different way of implementing it. What do you think? So it's a linear system. How do we solve when we have two unknowns? You need two equations. And we could set them both equal to b and then set them equal to each other. And that eliminates the b, right? Like, or you could use normal substitution or normal elimination. So I'm going to go back up and set them, give them numbers 1 and 2. And I'm going to subtract. Okay, I'll do 2. You do whatever you want. 2 minus 1, because that's going to eliminate the b's. So 58 minus 2 is 56. 27a minus negative a is plus a, so that's 28a. B minus b is 0. So what is a? Any chance that that works out nicely? 56 divided by 28?
Yep.
Nice. We call that equation 3. And I go 3. We'll go into 1 because that's pretty easy. And I get 2 equals negative 2 plus b, I think, right? Add 2 to both sides, and b is 4. We're supposed to find the values of a and b. We did. If you didn't get question number 2 from the other day, or a couple of the other questions like 6 and 7 from the practice last night, that'll give you a little tip about how you could go about doing those. Any questions? That's it for remainder theorem. Really small idea, but it's useful, right? Like if for some reason you needed to know the remainder, that's a lot easier than doing the whole division process. So that's pretty useful. And when you, I think if you spend a little bit of time thinking about that, the reason why, it certainly makes sense what that remainder theorem is, what it is. Okay? And then, like I say, there's lots of little kinds of questions that you can be asked about remainder theorem, but often it'll have the word remainder in the question. So you really want to, because we're going to do a special case of remainder theorem tomorrow, and then we're not really going to talk about it. Like we're only doing one day on it, really. So then people forget. So try to keep that in mind. Oh, look, it's still growing. What is going on? Yeah. Weird. Computer is haunted right now, I'm telling you. Okay, we good with that?